So let's look at the sum and difference rules for finding the derivative. Okay. To find the derivative, if I have got the derivative of f of x plus g of x, okay, remember the definition of the derivative says that the limit as h approaches 0, f of x plus h plus g of x plus h minus f of x plus g of x all divided by h. So I can separate just using my rules of fractions. F of x plus h minus f of x plus g of x plus h minus g of x. And then everything gets divided by the h. Now remember that everything getting divided by the h is the same as the first piece divided by h and the second piece also divided by h. Remember that in our limit rules, the limit of the first function plus the second function, I can find the limit of those two functions independently. So basically I can split these together, and the limit, that is going to be f of x, and that's going to be g of x. That is the definition of the derivatives. So this is f prime of x plus g prime of x. And basically all that means is if I've got functions that are this collection or the sum of individual functions, I can take the derivative of those one at a time. So example number 15, without doing all the workout and every single tiny step, what those rules above, the product rule tells me is that I can find the derivative of x to the third. Then I can find the derivative of negative 4x squared. And then I can find the derivative of 3x. And then I can find the derivative of negative 5. Remember that negative 5 is a constant. And the derivative of negative 5 then is going to be 0. So I can find my derivative in individual pieces. Okay. Number 16, I would do a little bit of work first. Negative 3 halves x to the fourth plus 3x squared plus now the square root of x. Remember that that is x to the 1/2. I'm going to set this up to be able to use my power rule. So the derivative now is negative 3 halves times 4. That's going to be negative 6 x to the third plus 6x plus 1/2 x to the negative 1/2, because remember it's n x to the n minus 1. 1/2 times the coefficient of 1 is 1/2. 1/2 minus 1 is negative 1/2. For number 17 and 18, for each of those, we're going to do a little bit of a preparation work here, which is something I always consider doing when I'm going to find a derivative. Okay, move this up just a tad. To have f of x equals 3x squared plus 5x minus 7 divided by x, the whole function is divided by x, but that also means that each individual piece is divided by x. So 3x squared divided by x, 5x divided by x, and negative 7 divided by x. So I can rewrite my function as 3x plus 5 minus 7 divided by x, but notice my 7 divided by x, I chose to write that as negative 7x to the negative 1. And then now I'm going to take the derivative. The derivative of 3x is 3. 5 is a constant, so its derivative is 0. And the derivative of negative 7x to the negative 1 is positive 7x to the negative second. And as far as I'm concerned, you're okay leaving x to the negative second as that is. For number 18, again, I'm going to rewrite 2x cubed divided by x squared is 2x. 4x divided by x squared is 4x to the negative 1. And then 2x to the 1/2 divided by x squared is 2x to the negative 3 halves. Using my prior rules of derivatives, 2 minus 4x to the negative second minus 3x to the negative 5 halves. Okay. product rule, and I really didn't talk about the difference rule, but it works the same, okay? That if instead of um, adding these functions here, right? Instead of adding here, if I was subtracting here, I would have had a minus in between, okay? And that really did play out number 15. Notice we're subtracting the 4x squared, so we're subtracting 8x. Okay, so there's the sum and difference rule for differentiation.